working out a confidence interval for the population mean where the population is not known to be normally distributed, the population standard deviation is unknown, where a large random sample has been taken. Hence, the central limit theorem applies. A sample of 200 observations, so n equals 200, are taken from a population with unknown mean, so the population mean is unknown, and this is what we're going to estimate using the 90% confidence interval, and where the population standard deviation is unknown. We can estimate the population standard deviation using a sample standard deviation, as long as we have a large random sample. The sample mean was calculated as 2.71, so x bar is equal to 2.71, and the sample standard deviation is 1.36. In the calculation for the confidence interval, we must be using a random sample, so we will assume that the sample is random, since there's no mention of the word random here. This is the formula to work out the confidence interval for the population mean, where we're using an estimated value for the population standard deviation. So we're using the sample standard deviation's value inside here. For a 90% confidence interval, we look up 0.95, so the cumulative probability to the left of this line, which is 95%, and table 4 in the AQA formula book will give you a Z value of 1.6449. So once again, this 1.36 is an estimate for the population standard deviation. Substituting the values into the formula gives a lower confidence limit of 2.55. So that's using the minus in the calculation, like this, and then changing the minus to a plus. This is the upper confidence limit, 2.87. So we're 90% sure that the population mean, which is a single value, lies between 2.55 and 2.87. So there's a 10% chance it's outside this interval. The method is similar to using this formula, but because the population standard deviation was unknown, we've used an estimate for it from the sample, which was 1.36. And there was no mention of the population being normally distributed in the original question here, so we've used the central limit theorem. And the central limit theorem, the CLT, states that for some unknown population distribution, so for something that's not normally distributed, the sample mean will be normally distributed. And this is true as long as we use a large random sample.